Hello and welcome. We are glad you have joined us. My name is Marco Estrada, and I'm a technical trainer specializing in Microsoft Azure infrastructure and security. I'm here to walk you through the AZ-700 course, Design and Implement Microsoft Azure Network Solutions. In this session, we'll cover Design and Implement Network Monitoring. In this video, we are going to learn how to sharpen our visibility across Azure networks using Azure Monitor and Azure Network Watcher. You will also learn about Connection Monitor, Traffic Analytics, NSG Flow Logs, among others, to spot the issues early. Let's get started. In this section, we are going to talk about how to monitor networks. We are going to explain what Azure Monitor is, implement Metrics Explorer, and how to use the Azure Monitor Network Insights. This diagram offers a high-level view of Azure Monitor. At the center of the diagram are the data sources for metrics and logs, which are two of the fundamental types of data used by Azure Monitor. The input on the left is the sources of monitoring data that populate these data stores. The output is the different functions that Azure Monitor performs with this collected data. These include some actions like analysis, alerting, and streaming to external systems. Focus on the network data collection. For example, inbound or outbound network bytes or packets. When you're monitoring Azure resources, one of the things that are being collected for you is the metric for each resource. So what you need to do is that you need to go to the Metrics Explorer, select the network resource that you want to use. Then you need to select the different monitoring metrics that we have available for you, define the scope, and finally select your metrics. These will give you a graph of the current monitoring of your Azure network resources. Azure Monitor provides you with network insights that will give you comprehensive and visual representation through topology, health, and metrics for all deployed network resources, without requiring you to do any configuration. It also provides you with access to specific network monitoring capabilities like Connection Monitor, NSG Flow Logs, VNet Flow Logs, and Traffic Analytics. Additionally, it provides access to Network Watcher diagnostic tools. Azure Monitor Network Insights is structured around these key components of monitoring: topology, network health metrics, connectivity, traffic, and diagnostic toolkit. Now let's take a look into Azure Monitor, see some metrics, and then later on go to Network Insights. Here we are at the Azure portal. You just need to search for Monitor to get this view. So the first thing that we're going to do is that we're going to move around just to see what options do we have. We can see the metrics that we are going to see in a little bit of logs, and if you scroll down within the left blade, you're going to see some insights. Let's start with metrics. In metrics, you don't really need to do anything in particular to start getting information from your Azure resources. Basically, you need to find the type of monitoring that you want to get. So in my case, I'm going to select Application Gateway, which is one of the services that we created before. And then later on, I'm going to review which metrics do we have available. So in this case, I have this application gateway on this specific resource group in my subscription. And what I need to do is I need to select and apply the changes. In the right-hand side, you'll see the different metrics that we have. So we have application gateway, total time, backend connect time, and so on. So we can just click one of those and start looking at the different information that it shows us. In this case, the backend connect time, which is an average metric. So we haven't seen that it has changed during the last few hours. You also might notice that there is a dotted line before. What that means is that we don't have information from that specific application gateway on that time frame. Now let's take a look on what we have on the Network Insights. Network Insights will give us important information about the network health of specific resources. For my particular case, I'm going to hide the blade on the left just to give you a closer look of what we have. You also going to see that I have this application gateway and I have some Azure firewalls, bastions, and some other things. So let's start clicking through application gateway. In the application gateway, we are going to get some generic information about the throughput, response status, failure request. Remember, I don't really did anything in particular here, so Azure is giving me this information by default. If I click through the throughput in this case, so it is going to take me back to the metrics, the one that we just looking at moments before. I'm going to close this one, go back to the Network Insights, scroll up a little bit more, just to show you that we have different other tabs within this view. We have the connectivity view, which I have two virtual machines connecting to two different destinations, a URL and a virtual machine. I'm not going to drill down right now because that will take us to a different tool in Network Watcher. Let me go to traffic, and in here, then again, you're going to see different network security groups, and just like in the previous example, these are going to be seen in a later demo for Network Watcher. In the top of the page, you'll see the Diagnostic Toolkit. Diagnostic Toolkit, well, those are also Network Watcher tools that we're going to review later, just like the topology one. So with that, let's go back to the presentation. In this section, we're going to learn how to monitor your networks with Azure Network Watcher. We're going to learn tools for monitoring, tools for network diagnostics, and also tools for traffic monitoring. Azure Network Watcher, it is a suite of tools. It includes monitoring, network diagnostics, and traffic information. You don't really need to do anything specific since it is automatically enabled for every Azure subscription. It can help you repair the network health of your infrastructure as a service products like virtual machines, VNet, application gateways, and many more. Network Watcher isn't designed or intended for your platform as a service products monitoring or web analytics. In the case of the monitoring tools, we have topology. It will provide you a visual representation of your network configuration. For example, you can see on the slide that we can see the network interface cards, the IP configurations, the virtual machines, even the network security groups associated maybe to your network interface cards or your subnets. On the other hand, we have Connection Monitor. It will provide you with an end-to-end connection monitoring for your Azure and hybrid endpoints. You can think of this like when you have a virtual machine and then you want to test a connection to a different virtual machine. That other virtual machine can be in a different network or even can be on premises. So you define a connection monitor to test that everything is going well. In the case of traffic tools, we have two different ones. In one hand, we have the flow logs that will show us information on ingress and egress of IP traffic through an NSG or a virtual network. Think for a moment in this specific scenario. Let's imagine that you're allowing a specific IP to go through that specific port by using your NSG rules. But normally you're not thinking about the things that are being blocked. So what we're going to get through the flow logs is all this information, all this raw data that all the connections that are going through that specific or not going through that specific NSE. On the other hand, we have traffic analytics. It will provide us with visualizations of the flow logs data. It will aggregate all these NSG and VNet flow log records and then later enhance those records with geography, security, and topology information. Last but not least, will provide us with analytics like traffic hotspots or maybe traffic distribution. Now let's talk about the network diagnostic tools. If you need to create a packet capture session to track traffic to and from a virtual machine or maybe a virtual machine scale set, calculate latency, find anomalies, then packet capture is for you. Another tool is the IP flow verify. It will check if a packet is allowed or denied to or from an Azure virtual machine based on the configured network security rules. Another tool is the connection troubleshoot. It will help us reduce the amount of time to diagnose and troubleshoot network connectivity issues, issues like DNS or missing routes. In addition, NextHub helps us determine if the traffic is being directed to the intended destination or whether the traffic is being dropped. This is specifically useful when we're using user-defined routes. Now, let's talk about some network troubleshooting tools. First, the virtual machine network troubleshooter will check if commonly used ports are blocked on that specific Azure virtual machine. On the other hand, we have the VPN troubleshoot, which will help us monitor and troubleshoot virtual network gateways and their connections. Now let's take a look at Network Watcher monitoring and diagnostic tools. In this demo, we're going to review what are the different monitoring and diagnostic tools Network Watcher has for us. Let's start with topology. Topology will give us a sense of what resources we have in different regions. So in my case, I'm going to select my Spain Central region. We can take a look that it has a peering with the North Europe region. It has a virtual network in it. And if I zoom in, we're going to see that my subnet, which is a default subnet, also has a network security group. Let's move on into the connection monitor. The connection monitor, like we learned on the presentation, it is about reviewing or doing some tests about reaching a specific destination. So in my case, I have two different tests. I'm checking the port 443 for a specific URL, and I'm checking also ICMP, or I'm doing a ping to another machine. You might remember this from the previous demo where I was telling you that we can review the connection from Network Insights. So let me hide for a moment the left plate to show you what is in it. So in this case, we have this connection monitor, which I call it check 443. It is going to tell me if some of the checks that I'm doing in port 443 are failing. It is going to tell me the round trip of all these different checks, and just to make sure that everything is working well. Also, it's going to tell me if there is some failing tests. In my case, everything is passing, and what are my different test groups, which we're going to review in a bit. Also, the type of test configuration, the source, which is a specific virtual machine, and the destination, which in this case is a specific URL. Let's go back to Connection Monitor. Within Connection Monitor, one of the things that I can do is that I can edit the test. And in here, we're going to review the different configurations that we are using. In this case, the Connection Monitor is based on Spain Central, which is the region where I have my virtual machine 3. The test groups, I have this virtual machine 3, so I'm going to click on it so you can have a closer look to it. And then you see the sources, destination, and the test configuration. In this case, the source is one of the virtual machines, the destination is a specific URL, and the test configuration is an HTTPS test. If I click through, what we can see is that there is a check on the HTTP protocol, so we can have TCP checks, ICMP checks. Take a look of the destination port, the frequency of the test. In this case, every 5 minutes, I'm doing a get to this specific path. Let me go back to my connection monitor rule. After I do configure all these different settings, so I'm ready to update the test group. Since I didn't change anything, let's just click cancel. The second rule that we have here is the check ICMP. So in this case, the name of the test group is a little bit different, but the idea is going to be the same. The only difference now is that when I'm looking at the test groups, it is going to check for ICMP instead of doing an HTTP test, and my destination is another virtual machine within my Azure subscription. Let's go back and click cancel. Last but not least, just like in this and the previous rule, there is a workspace configuration where I need to save all this information that I'm sending through the different tests. Last but not least, if one of the things that I'm collecting or reviewing with the connection monitor, it is not working correctly, I can create an alert so it can tell me what's going on. So in this case, the condition that I can create is whenever the count test result is greater than 2, is going to send me an alert. I will need to create an action group name for this specific case in order to get the different alerts. In my case, since this is a demo, I will not need an alert for this test. Let's review now some of the different network diagnostic tools. In here, we have a list of different tools that we can use for different purposes. Let's start with the IP flow verify. In this specific test, what I want to know if there is a flow that it is going through a specific or from a specific virtual machine. So let's select, for example, virtual machine 3, its network interface, and then the configuration that I want to do. The protocol will be TCP. I'm going to test an inbound connection to that specific virtual machine to the port 3389, and I'm going to use my public IP address, which is this one, and the remote port that I'm also using. For this specific scenario, we can go with this one. Let's click Verify IP Flow. Once the test is done, I need to scroll down a little bit to see if the flow is working or not. In this case, it is access denied. So what that means is that in my NSG that is associated either to the network interface card or the subnet of the virtual machine, it is not there. So in this case, the security rule that is kicking in is deny all inbound. So maybe we need a little bit more of information about this flow. So let's click on Energy Diagnostic now. In this tool, what we're going to do is then again, select the same virtual machine, which is virtual machine 3. We're going to select the protocol, TCP, inbound connection to the virtual machine, and you can see that automatically if the virtual machine has a public IP address, it will show up here. Since I'm connecting to that specific virtual machine, so I'm going to say that it is going to be the port 3389 that I'm going to test again, and my source IP will be the one that is displayed. Let's click Run Energy Diagnostic. Just the same as the IP flow verify, we need to scroll down a little bit more to see, well, the same result. The difference here is that I know now which is the network security group that is associated to this specific deny. So what I'm going to do is that I'm going to click View Details. In this case, Energy Diagnostic would tell me, well, what is my source IP, the destination IP that I was using, destination port, and the direction. So as we saw before, the traffic was denied, but now I have more details on which rule was the one that it was denying my specific access. So in my case, if I want to access my virtual machine from this specific public IP address, I probably will need to have another rule that overrides this one. Let's go back to the diagnostic tools. The next tool that we have available is the NextHub tool. So this tool specifically will help us to understand what is going to be the next step when a specific virtual machine is trying to reach a destination. For example, in this case, we're going to use the same virtual machine, the same source IP, and let's say that we want to reach my public IP. So normally, when I click the next hub, I'm going to get a system route. Let's scroll down to see the results, and yes, we have next hop type, it is internet, and this is a system route. But then again, you might have a configuration specific for your virtual machines that is going to use a user-defined route. Let's try that for a moment. I have in my configuration a specific route table that is configuring a specific change on the destination. So let's try this another IP address. So now we can see that the different next hop is virtual appliance, not longer internet, and the IP address or the next hop, it is different as well. And also it's giving me the ID of the route table that is associated to this change. So let's take a look into the next diagnostic tool. The effective security rules, it is similar of what we can get from NSG Diagnostic, but there is a twist in there. So let's take a look right now. We need to select the subscription, the resource group where the machine is, and then select the machine that you want to use. In this case, let's use again virtual machine 3. So what effective security rules is going to do is going to get all the different network security groups that your virtual machine has been associated with. It can be network interface card, can be a subnet, or even both. In my case, my network security group is associated at the subnet level. So what I'm going to do is I'm going to click into that specific network security group, and you are going to see that there's some rules that I have available here. So we have inbound rules, we have the default rules for that, and then we have the outbound rules as well, just like we saw in a previous video. But you might probably be seeing something different here, because let me show you what I mean by that. If you click directly onto the NSG, you'll see that when we define the rules for different places, you'll see sometimes any, you probably see other things like virtual network or internet, and then you probably don't remember what they mean to. So let me go back to the effective security rules. So when you see this one here, instead of saying any, you'll see 0 to 65,000, just like the same for virtual networks. Instead of seeing any, in this case the virtual network, you will see 0000/0. Another example is when you're clicking through that specific outbound rules where you see the different destinations for the internet. So in this case, instead of seeing the service tag, you'll see specifically what we mean with internet. Let's go back and take a look at the different diagnostic tool. Now let's use VPN troubleshoot. In the case of VPN troubleshoot, we will need to have a VPN network gateway. In our case, we don't have any available, so that's why I cannot do this specific test. But the idea behind it is that you need to select the virtual network gateway, then select the resource group, location, and storage group to save the information of the diagnostic. Now let's move into packet capture. Packet capture, like we saw in the presentation, it is about collecting network traces. So you need to create a new configuration where you need to select the virtual machine you're going to select the network traces from. So we need to select the resource group, virtual machine 3 in this case, or you can also collect it from a virtual machine scale set. So you need to define the name of your capture. So I'm just going to copy this for a later configuration. And then you need to define where are you going to save that specific network trace. If you have been doing this for long, you probably remember that network traces can grow a little bit big. So that's why you have the option to select an storage account, or you have the option to save it locally into the virtual machine, or you can select to save it in both. In my case, I'm going to configure that is going to save into a temp folder, and we're going to reuse the name and add the extension .cap. Last but not least, you need to define the maximum bytes per packet and the time limit per session. Since this can grow big, in my case, probably I'm just going to use 10 seconds. Then you need to define if you want to filter some of the packets. In my case, since it is only 10 seconds, I don't really need this thing on. But if you are collecting, let's say, an hour, you probably want to packet filter this specific collection. You need to define the protocol, local and destination IP, local and remote port. Let's remove that configuration and then start the packet capture. One of the things that packet capture will do, it is going to add an extension to that specific machine. So bear in mind that that is going to happen, and later on, just copy the file in order to analyze it later. Let's move on into the last diagnostic tool, which is connection troubleshoot. To be honest, this is one of my favorite tools because we can do multiple tests at once with connection troubleshoot. Let's select our virtual machine again. We can select another virtual machine as the destination, or we can specify it manually like an URI, FQDN, or IP address. In my case, I'm going to select another virtual machine. In this case, I want to know if I can reach my domain controller. Then you need to define which preferred IP version you are going to use. You can select both IPv4 or IPv6. In my environment, I'm only using IPv4. Then the protocol, TCP, and then the destination port that I want to check. In my case, I want to check port 389, and the source port, in my case, I'm not going to select anything in particular, so I'm just going to use 5555. Last but not least, there is a list of different tests that you can select from, and you're probably going to see that we have a couple that we already checked: Energy Diagnostic and Next Hop. Let's run the diagnostic test now. Once the diagnostic test is done, you'll see the results just by scrolling down. You'll see that the connectivity test did pass, outbound energy diagnostic also was allowed. We couldn't test, or we don't have inbound energy diagnostic test there, so that's why you see the deny. And the next hop as well, it is working correctly. You can also click on the see details to get more information about the different steps that this tool or this test did. You might probably wonder that, Marco, why did you skip traffic analytics? Because I wanted to keep this to the end, because traffic analytics works together with the NSG or virtual network flow logs. In my case, I do have configuration for virtual network flow logs. You need to enable this raw information to come into a specific log analytics workspace, and you need to select the different intervals that you want to analyze. In Traffic Analytics, we'll give you a quick look of what's going on within your virtual networks. So you can see how many inbound and outbound connections are we having. So we have allowed, blocked, banning, or malicious connections to it. And then if you scroll down, you're going to see the different regions your environment has, the different type of services that your traffic distribution has, like IP, subnets, VNets, or virtual machine scale set, and also other things that we can review, like ACL hits, application ports, network application resources like VPN gateways, express route gateways, load balancers, or application gateways, which in this case I have one, to get more information about what you can review. And with this, let's go back to the presentation. This concludes our session. Please review the following slide to remember some of the topics touched in this video. Pause the video now. Can you name the different Network Watcher tools and what they are used for? I hope you can. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.